It's great to be here today and to talk about a small tool that started some years ago. I hope that you're not too tired from your partying of last night. So we will do a kind of quick talk and we will make kind of interview-like presentations. And I will maybe start right away about why we started to work on CVE search. You know, when you start to do software developments, you do it because maybe of frustrations. And for the past year, I was a bit frustrated on not finding the right tool for doing vulnerability assessment, especially to search into all the vulnerabilities that are available for software and so on. And one of the key elements that was kind of a paradox, some years ago, when we wanted to do CVE search, the only source of information was basically NIST. And if you want to do search for your vulnerable software, you had to go to a US-based website. So for us, it was like, oh, yeah, is it really a good idea to do HTTP search query over the internet to search for about information about vulnerable software and so on? So that was one of the first requirements that we had, to find a way to do offline search, to have local search directly internally and not, propagate those search onto the internet. Something else that we wanted to have is, as you know, a lot of people are using intrusion detection systems or network intrusion detection systems. So basically, you capture a lot of network packet captures, traffic, and you want to do fast lookup. So if you have, if you have to query a remote services from the internet to basically look up for vulnerable software, for you doing pen testing or for doing regular assessment of your infrastructures, it's not really possible. So that's why we wanted to design such kind of software. Another problem that we see regularly is basically for vulnerability descriptions, they are not localized. So that means depending of your localizations, sometimes geographic localizations, depending of your business of activities, you want to better localize the vulnerabilities. And that's something that we really wanted to have in our software, is to be able to localize and classify vulnerabilities, because the surface of attack might be different from one organization to the others. Something else that we wanted to have is to have a kind of flexible data structures. As you know, information security is a big mess. I think it's not a lie, but it's something that we face every day. If you see vendors providing information about their vulnerabilities, they provide sometimes web pages in the best cases. Forget about parsing them. It's not very flexible. So we wanted to have a software where we could basically gather as much as information that we can get from the software vendors and put them into a flexible data structures. And I think from the first presentation that we have seen this morning, you see that a lot of people use Unix-like tools. You want to script everything you do, for pen testing, for evaluation, for security assessment. And we wanted to basically create a tools where you can use Unix-like tools for doing research into vulnerabilities. And basically, based on that, we want to provide a free software that people can use and even build new tools to improve security. So it was a kind of big goal. But everything started was in 2012. I was looking for a software for doing a CVE search. And by crawling the internet, I found out a small script from Wim Remes. I don't know if Wim is here. No. Wim, basically what he did start tools to fetch data from NIST and put it in the MongoDB database. And then the tools improve over time. I did some modifications. Pieter did a lot of modification on the website, and we will basically explain all the functionalities of the tools in the presentations. But I just wanted to show the history because we are not basically a kind of fixed structure, so we welcome more and more contributions. So if you want to contribute back to the software, we are quite open regarding contributions. So if you see bugs, security fixes, updates, new data source for vulnerabilities, contribute. It's how it works. So a quick overview of how it works. The key element of CVE search is to fetch vulnerabilities informations from different sources, put them in a database, and keep them flexible to do cross-references and cross-checking. So you have basically a core script called DB updater, and this Python script, by the way, CVE search is written in Python, Python 3. The DB updater is basically the core element for fetching all the data sources obviously the one from NIST, from the National Vulnerability Database, but from various sources too. So if you want to extend the software to add, I don't know, sources from Oracle, for example, you can fetch the data, and then you can create a small modules that will be called by DB Updater. And DB Updater is the one doing all the fetching at regular intervals, and doing even the notification for the indexer, for doing full text index and so on. So it's quite modular. It's all small Python scripts. And then on the back end, you have a MongoDB database that is used for storing the documents, so the CVE, for example, the Microsoft information about vulnerabilities and so on. And then we have an additional caching database called using Redis that we use for the web interface and the API to do fast lookup, especially when you browse element and search specific vendors and so on. So that's a quick functional overview of CVE search and how we populate the database. And we try to keep them as simple as possible to extend it to whatever thing that you want in the future. So what do we get right now? The main source of information is basically the NIST. So it's work done by MITRE, which is a kind of para-organizational structure from NIST that is doing all the work of collecting and doing assignment for CVE. But there are additional information that you can use from NIST. For example, there's a common platform enumeration called the CPE, which is very handy. It's basically the classification per machines and operating systems. And you see that there's a kind of nomenclature used for that one. And then you can find quickly an operating system, a version, and so on using this CPE. Then you have the CAPEC, the CWE, and you have other databases, like, for example, the official vendor statement. Because, as you know, for security researchers, sometimes it can be tough. Like if you ask for a CVE, sometimes the vendors might complain. So the official vendor statement is additional vendor statement, like, yeah, we know this vulnerability, we don't plan to fix it. Yeah, it happens sometimes. So it's a kind of statement that you want to add and to look at it, like that you know the official position of the vendors. And this provides cross-reference assignment too, so you have plenty of reference to, for example, MS values, so for Microsoft security vulnerabilities, back to the CVE values, because there are a lot of ID in use, and sometimes it's difficult to find back the information. Then we have two additional sources that are coming from external contributions, so the Microsoft built-in and the exploitation reference from D2 D-Square, which is a vulnerability framework. And we import another data feed called VFeed, which is doing a great work of cross-referencing. So like that, you have additional cross-references from the vulnerabilities. Things that you are interested in, if you know other public data sources that we can incorporate, let us know, because we are very interested into this kind of information. So now that you get all the data into the database, you want to do something with it. So we have a myriad and some tools that you can use. Basically, the most obvious one is searching. So you can search in the MongoDB database for specific things. We will make some example later on. You can dump the latest security advisory. You can, for example, classify the security advisory depending on a specific classification that you have internally. And you have some nifty tool like the search on Jabber or XMPP. So it's a bot that you can plug, and then you can query directly and search directly. You have the same for IRC. We have some additional tools for dumping CVE into ASCII Doctor, so you can view it with PDF and so on. So, you know, for corporate, sometimes they want to have, you know, those nice PDF and shiny PDF. And they have a series of tools that are used for the backend system, so the DB tools, and those ones are used for managing the database and adding some specific part. So how it works is when you clone the first repository, but you basically fetch for the first time all the information, so you can call the DB updater. That is straightforward to call. The -i means that you will be able to do the indexing at the same time, and then when it's imported, takes some time because the NVD database is more than 16 years old, so you have all the CVE locally now. Then you can start to search. And quick search, okay, I took Joomla because I think a lot of people are still using this CMS. I don't know why, but okay, it's another story. Then you can search on specific product names, in this case using the CPE names, and then it will return you all the matching CVE that you will find for Joomla. The screen is too small for Joomla. Then you can do additional queries, like for example for a specific CVE, and you will get automatically a JSON output with key values containing the vulnerabilities. Here it's again a Joomla reference. You see that you have what we call the vulnerable configuration part. This one is which versions that are vulnerable, and those one are using the CPE values. As you can see that you can have human readable lookups and a machine's readable lookup, so you can both enable or disable the -n the CPE value. So you can do a lot of script for with the JSON output. So just for your information, what is CPE? CPE is a static formatted information that you can use for describing a software or an application whatsoever. So it's designed by NIST. There are two versions, version 2.2 and 2.3. We support both versions. This one is a description of version 2.2. So basically, each software can be split into various parts, if it's an operating system element or applications, or applications means software in their case. You have the vendors, the products, the versions, the updates. As you know, sometimes you have vulnerabilities that are only applicable for specific versions or a specific language. That's basically was for the CPE.
Something to keep in mind is also that only the part, vendor, product, and version are required. So sometimes you have strange combinations where you also have the language, but not the addition. There are also other fields apart from the ones that are on the screen, but those are the most important.
Yeah, that's quite important because usually sometimes even the target of vulnerabilities is not really clearly defined on a specific version because they have no feedback from the vendor. They know that the product is vulnerable, but they don't exactly know the versions. And even sometimes you have vendors having no versions in their software. Yes, this happens sometimes. For SCADA systems, for example, it's quite common. So what can you do with it? A simple one. So for example, you want to check for all the top vendors that are using the word unknown. So basically, the security advisory gives a lot of information about vendor practices, what vendors are doing when they receive a vulnerabilities, what they disclose about it. And here you can do in one single Unix command. JQ, it's a very nifty Unix command for parsing JSON files and JSON output, and then you can do whatever things like, for example, getting a specific key or a specific values. In this case, what we are doing is we search for all the security advisory containing unknown, and then we parse it to just get the famous field, the vulnerable configuration. That's the one that you saw just before. And out of it, we cut the elements, we sort as unique, we count the number of times it appears, and then we take the top 10. And as you see that, for example, there's vendors that you might know, Oracle, have this tendency of setting unknown everywhere. So it's giving a lot of information about practices. You see Oracle and Sun are all together. Then you have HP, Google, IBM, Mozilla, whatever. But it's quite interesting because just as looking at how a security vulnerability is defined or described, it gives a slight indication of how the vendor is stretching the vulnerabilities. I think it's quite nifty. Then if you can go deeper, and as Pieter mentioned, that the CPE values can be sometimes extended, so you can have additional information, like for example here, the product names. So you are interested more into which product names are usually defined with unknown. And then you see a tendency of one single vendor, for example. Oracle, for example, is regular popping up because you see that they tend to use unknown for vulnerabilities. What does it mean? Does it mean that the product is more vulnerable? Not really, but it means that the management of vulnerabilities might be less precise by some vendors or for some product. For some of the product, it could be although that they release advisory, but they don't want to give too much details that someone can exploit it before it's fixed. And that's sometimes the approach of Google for Chrome, that they don't give all the detail at first glance, which is, I think, quite strange, but they do it like that. And then afterwards, we get more details when the patch is completely used and deployed. You can do many things. So if you are a fan of Unix tools, maybe some people in the audience are using R, the R packages, for statistics. So you can build statistics directly using CVE search. And one of the things that you could do is basically to get the CVSS value. And the CVCS value is a value that is calculated on regarding the impact that this vulnerability could have. And then you can basically extract the CVCS value for specific product, and you can even compare the value. So it can be used for various things. Imagine that you need to purchase a new software, and you want to see, okay, which one has the tendency of being more vulnerable than the others? Can you compare both of it? So for example, when you do a request for proposal for buying a new vendor, maybe you can have a look at this one. Assuming that the vendor is requesting CVE or at least publishing security advisory, which is not always the case, you can use this as a kind of metric to evaluate if a vendors have a tendency to have highly impactable vulnerabilities compared to low impact vulnerabilities. And you see an interesting trend. Sun has been purchased back by Oracle at some point in time, so the CPE value changed. So that was quite interesting because at some point in time, Sun has been moved to Oracle, but the old vulnerabilities were still from Sun. And you see that the median for the CVSS from Java, and the GRE at that time was GRE, moved from a median of 7.5 to 10 for the CVSS, meaning that the exploitations could lead to a complete abuse of the systems or abuse of the vulnerability. So that could be one of the use, but you can do plenty of other statistics with it, and I'm pretty sure that you can come out with great idea for ranking software.
Also, the CVSS is based on the CIA model, so confidentiality, integrity, and availability. And it's also based on how easy it is to exploit. So if it's on a network, if it's local system, if it's easy to hard, and all those kind of things. So it's not just what's the impact, but it's also how easy is it to exploit. So it's a bit of a risk indicator.
Right. Something else that we wanted to do is the local exploitation, and I think we have the same problem in our both organizations. You have in some huge organization, you have different departments. So the view of the department is depending on what they use as software. So I'm pretty sure some of you are working in the IT field and they might work in the ICT department of big corporations. Then you have a huge accounting department and they might use SAP, for example. So with CVE Search, what we design is a ranking mechanism, which is very simple. So you can basically add a rank for specific groups, matching a specific CPE values. So as an example here, what do you have? We created a tag which is called accounting, can be anything you want. And if it's containing SAP in the CPE values, it will set a ranking value. The ranking value could be anything you want. So you can have your own scale in the corporate environment. We tend to use 0 to something unknown to 1 to 3 for the ranking up to 3. That means that it's highly impactable in the organizations. But you can use it as a new ranking scheme that you use internally. And then you can afterwards use the tools to look into some CVEs that are matching your ranking. And then, for example, if you have an accounting department having their own IT staff there, you can forward them the specific CVE and vulnerability matching those CPE with high ranking that they need to fix it before some other activities that they have to do. Another example of using ranking, there is a tool called dump last, which is able to dump the last security vulnerabilities. That's a thing that a lot of security departments are doing, looking at the latest vulnerabilities. What you can do with it is you can only dump the one where you have a ranking. So you don't, if you don't, for example, have some software, you don't want to see all the vulnerabilities associated to software that you don't have in your company. So you can use dump last, and -R means that you just want to see the last vulnerabilities with a specific ranking. You have different output formats, then you can parse it for things. For example, I know some organizations that are doing it for putting them on the intranet or the IT staff intranet, so like that they can have a look directly at what they need to patch. Something else that you can do with it, it's in the full text search, you have a visualization scheme. So it's supporting JSON files where you can see terminology that is used or terms. And that's one of the examples of usage that you can do with such kind of search.
This is the screenshot of the web interface that I made. And on the web interface, you can see 3 different colors. The black one means it's normal CVE. Then the gray one means that you have already seen it. And this is great if you want to keep track of which CVE have I seen, which have I not seen. The one with the eye and in purple is a blacklisted CVE. And on the next slide, you will see that we have a black and a white listing system. And then, of course, the red one is the whitelisted one. But the difference between whitelisting and ranking is that we assume that we want to see everything, not only the whitelisted stuff. An example would be if you have a Linux system. A Linux system does not exist on its own. There is a lot of subcomponents, and you might have not whitelisted all the subcomponents. So if you see one, yeah, maybe this is also vulnerable. And so the second one is where you see the white and the blacklist. This is an example of the blacklist. You can blacklist on CPE code, and it works as a regex. So if you want to say, okay, I'm not going to blacklist a specific version, but I'm only going to blacklist up to the product, then it will blacklist all the versions. If you want to go a bit more specific or a bit more generic, you can do that as well. And on the right, you can see the target software. That is for example, applications running on Android. At our company, for example, we don't use Android, so we are not interested at the hundreds of vulnerabilities on Android applications. So we just blacklist all applications running on Android. The top one is an example of the filter. The filter you can see on here as well, but there it's collapsed. And the filter allows you to, well, filter the CVEs a bit more specifically. The blacklist and the whitelist, you can either turn them off, on, and then the blacklist will hide the CVEs that you have blacklisted. You can turn them off, then they won't mark anything. And you can put them on mark, so then you will also see the blacklisted stuff in the color that you saw on the previous slide. There is the management tool repository that I made. It's just a collection of little scripts that we used that I want to share with everyone. Everyone is free to add their own scripts, their own tools. And there is also a few lists of CPEs that I just made while I was doing my work. And one of those lists, for example, is a list of content management systems. So if you're not using any content management system, just import that in the blacklist and you won't see any. We also made an API. The API is used for either your own scripts or tools that we already made. We have the API running in both the normal web server and the minimal version. The minimal version is more or less the same as the previous, so more or less the same as this one, except you don't have these features. You can search still, but you won't have the scene CVEs because we're not going to keep track of everyone that's watching it. You won't be able to black and white list for obvious reasons. And the API is in REST format and returns JSON. There is a public version running on the cve.circle.lu. And there are a few queries that you can do. We have the ability to browse specific vendors, specific products. We also have the possibility to just get information from a specific CVE, get the last CVEs. One that I see is not on the slide is you can also get the CVEs that are applicable for a specific product, specific version, specific whatever. And you can also use a few of our internal tools that are used to, for example, do the translation between CPE 2.2 and 2.3.
Just one thing for the API. There are some pen testers relying on the API for their tools. So if you want to do quick tests and so on, you can use a public API in the configuration, or you can basically run your own installation on your systems. So you can basically use both depending on your needs. So there is no force to use a public API. It's just up to you to decide. Yeah, this one is a long story. The thing is, at some point in time while we were looking at CVE search, it was for a research project that we had called Toringe. It was a research project for doing analysis at Torexit nodes. So the idea was basically to monitor and what kind of the level of vulnerabilities of end user are using Tor. And at that time, we had no tools for doing automatic detections of those machines that are using, for example, older browsers or older applications. So what we did is, it was a quick hack at that time. So we were using a database with the CVE. So nowadays with CVE search, indeed, this could be abused in any way. So that means someone who wants to do automatic exploitations could indeed use CVE search for doing automatic exploitations. But that's the two sides of software, and that's something to keep in mind. It's free software, so people can use it for whatever purpose they want, but always think of what bad guys could do with it. But that means for pen tester, for example, or for people doing security assessment, they can run or do analysis on the pickup files, do fingerprinting of browsers, and then detect which browser could be vulnerable and so on. So that means, yeah, indeed, we write software that could be used by bad guys, but could be used for good guys. And until now, we have seen a tendency that a lot of people are using for the good than the bad. Okay, this one is, for us, I think, the most important one. It's looking for open data sources of software vulnerabilities. And I think both of us faced the daily situation where we had wonderful websites from vendors, using Flash sometimes, publishing sometimes reports in PDF documents with their vulnerabilities. So there's no easy way to parse their information and to collect the information. So we want to give a little challenge for you or for vendors. So if a new vendor or software vendor or hardware vendors provide an open data source feed that is easily parsable, they are eligible for either 1 kilogram of Belgian chocolate or a pack of 6 Orval beers. For the beers, it could be negotiable to other beers if needed. But that's, for us, it's really important. And what we have seen in the past is that vendors are not really playing fair, not all. Some are doing quite well. I mean, for example, Red Hat are publishing all their documents and so on. Microsoft is going better, but there are still plenty of vendors that are not even publishing their security vulnerabilities. And when they publish something, it's something that you cannot automate or parse it automatically. So if you know one vendor that provides a new feed, yeah, they can be eligible for 1 kilogram of Belgian chocolate. No, the thing is, we are interested into data set of using CVE search. When you use CVE search, you can enrich the information around vulnerabilities with localized information. For the case in Luxembourg, what we do, we have a database of all the CVE, and it's linked to the vulnerabilities and the exploitation that we have seen. So that means linked to the incident. So we have what we have is a list of all the incidents with their CP correspondent, and then we use it to rank the probability of infections or abuse using these vulnerabilities. Then it's really linked to the country, usually, because it's depending on what kind of software you have in the country, and it's depending on what kind of target or attacks you get into your country. So we are really interested into improved or extended classification of the dump. So if at some point you see, for example, for a sector of activity, I mean, industrial sector, you have a list of CPEs, like you mentioned, for the CMS, but for example, for the ICS sector, we are interested into this, to incorporate it back into CVE search, so like that people can have customized version of CVE search for their specific activities, to be not overloaded with all the information that you get from security vulnerabilities. Something that we really want is sometimes we have to push vendors to release their vulnerability informations, and that's a very tough one because sometimes they don't want to do it. Sometimes they want to do it, but they change the URLs, I don't know, every 2 weeks. So if you fetch the information and you have to change the URLs every 2 weeks, you need to update your software and so on. So it's something really important that should be, I think, in vulnerability disclosure of vendors, that they provide a way to give the information. Another issue that we have seen is, and I think this one is the trickiest one, the CPE naming convention is coming from NIST. And it's very difficult to find the matching with some operating system or some libraries in an operating system. One of the good examples, and every one of you I think knows this one, you know OpenSSL, they have some vulnerabilities sometimes. If you look at Debian, it's not called OpenSSL, but it's sometimes called libSSL. In some other distribution, it has different names. And then people are even backporting fixes from one version to another versions, but you cannot do the matching between the CPE names that is mentioned in the vulnerabilities with the real name that you have on your operating systems. And at some point, we really want to give a call to all the vendors to say, okay, guys, it's nice, but please try to have a mapping database with all the CPE values, at least from the, each libraries. I think it will ease the pain of everyone, and it will be a thing for system administrator to better at least be notified of security issues.
Another problem that we saw with CPE is, for example, when Flash is vulnerable on Linux but not on Windows, what they do is not put the Linux part in the CPE like it should be, but they just add both CPEs to the vulnerable configuration. So they add the generic CPE for Flash, and under that, the one for Linux, which is also very difficult if you want to automate processing CPEs.
Yeah. So if you want to help, and if you want to use it, there is two main repos for CVE search. We just, by the way, created an organization yesterday that where all the thing will be. So I'm basically maintaining the stable versions because we have a lot of operational part, and Pieter have basically the unstable one, and we merge every weeks and even sometimes months, depending of the changes, back into the version, and then you have stable versions. So based on that, just to go back to this one, there are other software using CVE search that you can use too. Some are written by some other partners, some other people. For example, the CVE portal is a notification portal where people can register their software and get notification later on. You can mention maybe CVE scan?
CVE scan is an idea that I had. When you make an Nmap scan, sometimes you can find CPEs in there. So CVE scan will either work with scans that you already made or scan itself or scan all systems. You can do one or multiple systems, both work, and then it will automatically correlate the CVEs. So you get a nice overview. It looks the same like in CVE search, a big list of all the CVEs that are applicable to the systems that you just scanned. And it's not implemented yet, but the next step that I want to do is from there, if there are Metasploit modules available, automatically exploit systems. It works both on web interface and on terminal. So with, I forgot the curses, yeah, that's the library. And then the management tool is something that I'm working on at the moment. Basically what I want to make is a big management tool that can be used with CVE search directly. So when new CVEs apply, you can make systems in the management tool, systems where you add all the CPEs and assign teams that have to fix those systems. And when new CVEs pop up, the tool should automatically add new tickets to those people that are responsible for the teams with vulnerable software.
So we have plenty of ideas and new things that we want to implement. One of the things that we are right now working on, and that might be quite important, I think, in the future, is to basically expand the systems to vulnerabilities that does not include CVE assignment. And that's, I think, one of the biggest issues nowadays. You have a lot of software vulnerabilities that never receive a CVE for various reasons. Sometimes the vendor doesn't want to provide it. Sometimes the vendors want to provide it. So what we would like to do is basically using CVE search as a kind of pre-assignment CVE. So that means the web interface or the interface would be there to help someone, a security researcher and so on, to already pre-fill all the information for doing a CVE request. If they want to do a CVE request, they are doing it, or we keep the information locally and so on. So the thing is to basically have a kind of vulnerability management within the platforms before that the CVE is really assigned, because for some large organizations, they have even teams that are basically managing their own vulnerabilities, even if those ones are not disclosed. And going back to that one, we really want that more and more vulnerabilities, data sources are included in CVE search. So if you know about some interesting one and so on, please let us know. The only thing that we have seen in the past as issue is sometimes you have licensing restrictions of the data set. So the one providing the data source is putting additional restrictions, and by doing so, it's limiting the ability of using CVE search. So we really want that the data source that we get are freely accessible and can be reused for whatever purpose.
To go back on that, the data source of vFeed also includes things like links to Red Hat advisories, exploits in exploit database, exploit using Metasploit, and all those information. So that information is also very welcome. Something
that we really want to do too is basically improve the data structures to make it a bit more flexible. And I think we really want to reduce the code size. Even if the code right now is not so big, as you know, for security, it's not a good thing if we have a huge code base. And we want to keep it as simple as possible. So one of the objectives too is to reduce the code size of the systems. So even if we provide more functionalities, is to basically rely on less software. And obviously the last one, and this one we will do a separate project for that. It will be a documentation, not only for the one using CVE search, but especially for the one contributing, to ease people to contribute back to the systems, especially regarding adding new modules or new data sources. We will provide the documentations, how to use the API, how to use the libraries, and how to get the data format into the database.
A good example from that is that in the code we have a library purely for querying data, and one of the developers that wanted to contribute basically rewrote the entire query library because he didn't know it existed and didn't really look for it either. So we also want to make it easier for people that want to develop, so they know what is available, what's not available, how to write code so that we keep a generic format and that it's easier to review later.
And the thing is, so basically I think that's it for today. So if you want to contact us, here's our contact details. If you have some idea or extension that you want to see in CVE search, let us know. Even if you don't want to code it, feel free to open an issue with an idea. We welcome new idea or new things that could be implemented. So go on GitHub, open an issue, and then we will have a look at it.